y. Here's the pretty constructor. Notice it takes 3 parameters or 3 arguments. It initializes the size, my x and my y. It has an inflate function, it has a show, and currently I've instantiated or created an instance of Bob, okay, starting at some random x coordinate, y coordinate, and also a random size. Bob shows himself. As I press play, okay, there it goes, okay, with a random size, random position. There's another random size, random position, and yet again, third random size and position. We're adding on to this, going over overloaded constructors, which means you have a constructor that could look like this. Okay? Notice this one has no arguments. Constructors have the same name as the class definition. So in this no argument constructor, no information is given. My size will be initialized to be like 10, so we can at least see it. My x will be at 0, and then my y will be at 0. Currently, we have 2 constructors. There's no information and 3 pieces of information. See that? Having more than one constructor is called overloading the constructor. You're giving it much more information than necessary, but now the user has more control over what you want. The very first instance, the very first time you make a balloon, now I've written 3 constructors. Okay? You could give it no information, 2 bits of information, or even 3 bits of information, and the computer, your Java program, knows what to do with it. Okay? Currently, Bob exists like so. Let's make a demonstration of these other 2 constructors at play. Okay, I'll pause here for a moment in case you're copying this down. What I'll be writing next is I'll be instantiating like Jim and Sue to use these 2 constructors. Okay? I'll post this all to Google Classroom for your reference, so don't feel stressed on copying it, but there was your moment in case you're following in the classroom. Okay? So from here, let's go ahead and make those balloons. What was it? Sue and Jim, let's say. In here, let's instantiate Jim to be a new balloon. Jim will be the boring, no argument one. Sue will be a bit more interesting. Let's make Sue always appear in the center of the screen. Okay, balloon, thank you. It is a balloon. Oops, like so. And let's say the center of my screen will be, let's see, where is the size? Size? 300 by 300, so Sue will be in the middle, okay, at 150, 150. And so that each balloon shows themselves, gotta do something like that, okay? As I press play, we should see 3 balloons, okay? Very tiny. Jim is up there at 0, 0, okay, where my mouse is. Notice it has no arguments. Sue is currently in the center because that's where we told Sue to be. And then Bob generates random size and XY coordinates. Let me run and play it again. You'll see that Bob will move. You see this time around, Bob is super tiny. That's Bob right there, okay? One more time to convince you that Bob is random. Ta-da, Bob is huge, and now it overlaps Sue in the middle there, okay? So that's the first new idea, overloaded constructors. Sometimes you can have more information than necessary. But notice, right, I didn't give any information on how to handle like 1 argument. See that? That's going to cause a mistake. I didn't tell the balloon what to do if I just gave it 1 number. See that? If you squint really carefully, it says constructor balloon taking int doesn't exist. Okay? You have not defined how to handle this case where you only have 1 bit of information. Cool? 2 bits of information, 0 or 3. So far, so good? That's overloaded constructors. Next up, let's do something a bit more interesting. Let's have our balloon, let's see. Let's have our balloons move towards our mouse. Is that what I want to do? No, let's pop, okay? We're going to pop our balloons. That's the first demonstration, okay? And the logic here goes, if the mouse is within 20 pixels of the balloon, then pop, okay? So you know that this is going to involve an if statement of some sort. And then inside, what does it mean to pop? We're going to change my size to be equal to 0. Does that make sense? Once you had size and now you don't have size, you've visually popped yourself, okay? And this time around, let me introduce the distance function. This is the computer's implementation of the Pythagorean theorem. It needs an x and y coordinate, and then it needs another set of x and y coordinates, and it will calculate the distance between the two, okay? One of them will be my x, the other one will be my y, okay? And then we have to be able to check where the mouse coordinates are. In processing, the mouse coordinates are stored in this variable, MouseX and MouseY. Notice the capital X and the capital Y that is present, okay? And I put these as inputs into my distance function. Right now it gives me an error. It says it's not a Boolean because this will return a number, okay? If this distance is less than or equal to my size divided by 2. Why is it divided by 2? Well, based on how we define ellipses with width and height, okay, that's the diameter, okay? So if you're within 1 radius of your center, then you know your mouse is hovering over a said balloon. Does that make sense? And if it's less than that, that means you're in the balloon versus out of the balloon. Okay, this is what it means to pop. Distance function will be useful. For your chemotaxis, maybe you want to do something special when it gets too close to your mouse, too close to some food source, too close to each other even. So there's the introduction to how this one works. We want to make sure that each of these things, like Bob needs to be able to pop, Jim needs to be able to pop. Oh gosh. So you see how it turned blue? I think I want to change its name. There's probably a conflict. Pop is already a function that exists in processing, so we'll call this Poppy, okay?
Pop is for like blind.
Yeah. It's already a reserved keyword, so that's why it turned blue. I changed my from Pop to Poppy, okay? So Jim, Sue, and Bob will be Poppy. So, okay, notice right now, my mouse is like very far away. It's not within 20 pixels. As I move closer, and closer, and closer, oh gosh, it's coming, it's coming, it's coming. Yeah. Why? Okay, one mistake, yes? Let's go ahead and change this order. Show should be the very last thing you do. Let's try again. All right, moment of truth, come on. Blast. Foiled again. Okay. I've done something wrong. Anybody know what I did wrong? What's up, Ryan? I have to draw the thing again? Draw over it. I need the animation. You're right, because if it is permanently there, if it is popped, I still have the stamp, yeah? Alright. How's this? Alright. Haha! Pop! And this one's too small to pop, but I did pop it. Let's try that again. That was pretty fun. Alright. Ready? 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 Boom, boom. Okay. Ta-da! We pop balloons. Alright, next part. More interesting. Last part of today's demo. Okay? This one will be called avoid, this member function. What does avoid mean? That means that since my balloons can be popped, oops, okay, we want our balloons to now be smart enough to move away from your mouse. So what does that mean? That means if I start getting closer, I want this balloon to randomly walk away from my mouse, okay? For time consideration, we'll just do this one-dimensionally in the x coordinate. You leave it to you to think about x and y coordinates together to move away, but the idea should still be present, okay? So a little bit of explanation on how this avoid code will work, okay? Notice, right now, my mouse, which is very big, because Mr. Chen loses track of his mouse very often, so the mouse is on the left-hand side of my balloon, okay? Versus being like on the right-hand side. I still have to remain on the canvas, but you get the idea, right? These are the two cases you must deal with, okay? If the mouse is on the left, and you want to move away from me, should you move right or left? Okay, if I'm on the left, do you want to go towards the left? Do you want to go towards the bad person?
Yes.
No, don't go towards the bad people, okay? Because you don't want to get popped like that, okay? So you're going to move to the right. It's opposite of where the mouse is, okay? So code-wise, you're still going to use some distance calculations or do some kind of calculating. So this first statement will be if balloon is on, or if the mouse, let's do if the mouse, is on the left of the balloon move or randomly walk towards the right side of the screen. Okay, let's see what this looks like in terms of code. That will look like doing some subtraction. If your mouse X is on the left compared to your X coordinate, should this be positive or negative? Let's demonstrate. Oops. Let's comment this out and then try to demonstrate it, okay? So just focusing on left and right, currently, if I do my mouse coordinates subtract like the center, 150, 150, will that number be positive or negative? Mouse X minus the center, let's look at the one in the middle, right? Where's my mouse coordinate approximately? Like 50 pixels, let's call it, right? 50 take away 150, is that positive or negative? Negative. Good. Okay. So if it's negative, it's less than 0 or equal to 0, sure. Okay. We want to do the new part. Okay. And this will demonstrate a random walk, a biased random walk. So it looks like my X coordinate, we're going to slowly shuffle away. Okay. This is the random walk pattern, math.random. And previously, we did something like times 3 and then minus 1, like that, right? This generates a number between, it's either 0, 1, or 2, okay? When you subtract 1 from it, it becomes negative 1, 0, or positive 1. You see how in this 3-number example, there's one positive number, one 0, and one negative number, yeah? It's even. It's not biased towards a direction. It has equal chance of going left as is equal chance of going right and even staying the same, yeah? But when we want it to move randomly towards the right, we want something that looks like negative 2, negative 1, 0, 1, 2, 3, 4, something like that. You see now there are more possibilities for it to go towards the right-hand side. There's more positive numbers, see that? So how would I modify this math.random expression to get something that looks like this? Where do you start? I'll answer my own question for the video's sake, but you're welcome to pause and think for yourself. So 1, 2, 3, 4, 5, 6, 7. I want 7 things, okay? And then I'm back shifting this by, looks like I'm shifting it by 2 numbers, okay? So this should match up with this desired output. So let's see, and fingers crossed it will work, okay? Because it didn't work last class and I failed miserably. So this is what it means to avoid one-dimensionally, okay? The mouse is going to be, I can spell, okay? The mouse is on the left-hand side of my balloon, so it's going to slowly move towards the right. I want to be sure that each of these, I call this avoid function that I've written. So I'm going to type that in right here, right? Bob will avoid, Sue will avoid, and Jim will avoid. It's getting closer, and we should see some movement. Let's see if that happens. Okay? Oh, okay. So it's on the right-hand side, right? I didn't write code for the balloon to be on the right-hand side, okay? And then suddenly, I'm going to move to the left-hand side. See how that one goes away? Yeah, they slowly run away from me. But what's weird is, all right, why are these balloons such cowards? I am not remotely close to you all. See that? Like there, right? And yet it keeps running, correct? So really, the animal, or this balloon, right, is a smart balloon, right? It's only if the mouse is close, and then I go over, should it actually run away. Does that make sense? Yeah? So we introduce another section. We want this randomness to be, consider distance too, right? If you are close to it, then do you start running, okay? Make it a bit more realistic. So let's say if you're within 20 pixels, let's say, then you start running. So what does that, oops. Unexpected token, I misbalanced parentheses like that, I hope. Play. And so now, okay, notice now I'm on the left-hand side, but I'm not close enough, okay? These balloons are not cowards. Only do I approach them within 20 pixels. I popped that one. That one's not very smart. I guess I should do it as a function of size, right? Oops. Let's do my size divided by 2 plus like 20, something like that, okay? So now, if I get close enough, run away, little balloon, run away, I'm gonna get you, I'm gonna get you. See how smart they are now? Okay. Not fast enough, balloons. Take that. Okay. So, main ideas are a biased random walk. Notice how this is biasing towards positive numbers, okay? Versus just all being equal. This is how you run away, and the reverse logic is running towards your mouse. This may be useful for your chemotaxis. All good? That concludes my videos. Any questions from the class? None? Then I will post this for you to learn from and redeem myself from my earlier classes.